Hello students, welcome to Trunkie Academy. I am Dr. Pallavi Kulkarni, your chemistry teacher, and today we are going to discuss the topic from chemistry, which is specifically from organic chemistry. The name of this topic is diazonium salts. Let me first of all write down the title of the chapter. The title of the chapter is Organic Compound Containing Nitrogen, and the title of the topic is diazonium salts. Okay, yes, let us discuss this topic. So as far as amines or organic compounds containing nitrogen chapter is concerned, we have discussed about the amines previously. We have discussed about structure of amines, we have discussed about nomenclature and isomerism in amines, we have discussed some of the reactions of amines in the previous session. Now diazonium salts are one of the organic compounds which are also contain the nitrogen atom in them. They are also produced from amines only. Okay, they are also produced from amines only. Okay, the reaction by which they are produced is called as diazotization reaction. The reaction by which these diazonium salts are produced, they are called as diazotization reaction. This diazotization reaction starts with, or it is the reaction of the primary aromatic amines. This is given by only aromatic amines, or this diazonium salt produced by aromatic amines are stable. Other amines also give, aliphatic amines also give this reaction, but these are not stable. I'll explain all these things. Yes, so primary aromatic amines, that is primary aromatic amines means what? The aromatic ring directly attached to NH2. They are treated with, primary aromatic amines are treated with the NaNO2 plus HCl at 0 to 5 degrees Celsius. 0 to 5 degrees Celsius, that is 273 to 278 Kelvin. Okay, to produce diazonium salts. Okay, this is called as the diazotization reaction. Okay, so what is diazo means? Here di, in this diazo word, di stands for 2 and azo stands for nitrogen. So it contains 2 nitrogen atoms which are connected to each other by a triple bond or double bond in its resonance. So this group is called as diazo group. Okay, this group is called as diazo group. Diazo group is introduced in the molecule. Okay, and therefore it is called as diazotization reaction. Okay, let us see the reaction first of all. General reaction I will write down first of all, and then we will see the mechanism for this reaction. Okay, so aromatic amine, I will take the example of aniline. Aniline means benzene ring attached to NH2. Okay, benzene ring attached to NH2. This is aniline, which is a primary aromatic amine. Okay, primary aromatic amines. Okay, it is treated with what? It is treated with the mixture of NaNO2 plus HCl. Okay, at very low temperature 0 to 5 degrees Celsius, and we are getting the diazonium salts. Okay, so what is the structure for this diazonium salt? It is like this: N triple bond N, positive charge on this nitrogen, and Cl minus is the counter ion. which is called as benzene diazonium. As chloride is the counter ion, instead of salt I will write down chloride. If it is bromine, then bromide, and accordingly we will change the name. So this is the general reaction for diazotization. Now here, if you can see, this reaction is carried out at low temperature. There is a reason for this. What happens in this reaction? This NaNO2, which is called as sodium nitrite, it combines with HCl, that is hydrochloric acid, okay, and it gives you HNO2 plus NaCl. Okay, so this HNO2, it's not HNO3, it is HNO2. HNO3 is nitric acid, HNO2 is nitrous acid. HNO2 is nitrous acid. This nitrous acid is stable at low temperature. Okay, as it is stable at low temperature, we are maintaining the low temperature 0 to 5 degrees Celsius during the course of reaction. Now this HNO2 is highly unstable. Okay, this HNO2 is highly unstable. Therefore, this HNO2 is, that is nitrous acid, is in situ prepared during the reaction. In situ means what? That is, this HNO2 is so unstable, we cannot prepare it and store it in the shelf, right? If we store it like this, then it will undergo decomposition. It will not remain HNO2 anymore. Therefore, whenever it is required, we are going to prepare it at the time of reaction or during the inside the reaction mixture only. During the course of reaction mixture only, which is called as in situ preparation. Which is called as what? In situ preparation. Why HNO2 is prepared in situ? Because it is highly unstable. Okay, so this is what the basic idea about the diazotization reaction is. So you can do one thing, you can just take a screenshot of this page first of all, and then we will see the mechanism for this reaction. I hope you have taken a screenshot. Now, after this, we are going to discuss the mechanism for this reaction, mechanism for diazotization reaction. As I have told you already, in diazotization reaction, we are using HNO2 in C2, right? So that step I have already explained to you. That is how HNO2 is prepared in C2. That is NaNO2 combines with HCl, hydrochloric acid, and we are getting this one. Okay, so first of all, in the mechanism I will show you the structure of this HNO2. We are going to discuss the mechanism of diazotization reaction. You will never get this kind of detailed mechanism in any of your textbook, so please listen carefully. Okay, so this is mechanism for this diazotization reaction. So in this reaction, what I have told you, HNO2 is prepared. Okay, so HNO2 is prepared in C2 like this. NaNO2 combines with HCl. We are performing this at low temperature because HNO2 is highly unstable, 0 to 5 degrees Celsius, and we are getting HNO2, right? Okay, so this HNO2, which is nitrous acid, the structure of this nitrous acid is like this: HO N double bond O. Okay, so oxygen belongs to group number 16 and nitrogen belongs to group number 15. Oxygen attached to 2 lines has 2 lone pairs of electrons, and nitrogen attached to 3 lines has 1 lone pair of electron, right? So this is the HNO2. HNO2, that is nitrous acid, OUS acid. Okay, so what happens further? This nitrous acid combines with H plus from HCl. H plus, that is acid we are using, right? It reacts with the H plus from HCl. So what happens here? This oxygen abstract this H plus, as oxygen is having more electronegative than nitrogen. Oxygen will attack on H plus, and we are getting this further structure like this. Other things will remain as it is. Okay, so on this oxygen here, it has lost 1 pair of electrons, so it will carry a positive charge, and it is bonded to hydrogen, right? It will carry a positive charge. Nitrogen 1 lone pair, the another oxygen 2 lone pair of electron. Now this step here which I have written, in this step we are going to add the proton on the oxygen, right? Therefore this is also called as protonation. Okay, this is also called as protonation step, and the product which is obtained will be called as protonated nitrous acid, right? Will be called as protonated nitrous acid. Okay, now this protonated nitrous acid again is unstable because you can see there is a positive charge on oxygen. What happens further? This bond gets shifted on oxygen because oxygen is having positive charge which it does not like. Okay, electronegative elements do not like that they have the positive charge on them. So what happens here? So here we are getting two things. One is the N double bond O, in which nitrogen carries 1 lone pair of electron, oxygen carries 2 lone pairs of electron. But here can you see guys, nitrogen is carrying 1 lone pair of electron but only 2 bonds. What is the tendency of nitrogen? Nitrogen is a group number 15 element. Its tendency is it should be attached to 3 lines, by this, or by this. Okay, by any of these 3 ways there should be 3 lines attached to it, but there are not 3 lines present in this structure. Therefore it will carry a positive charge, right? Therefore this nitrogen will carry a positive charge. This particular ion which is produced here is called as nitrosonium ion. It is called as nitrosonium ion. NO group is called as nitroso group, and there is a charge present on it, therefore it is nitrosonium ion, right? It is called as nitrosonium ion. Apart from that, what is produced? Can you see here this another portion? So this is oxygen attached to H and H, right? This oxygen now carries 2 lone pairs of electron. which is nothing but water. This molecule is water. So water is a byproduct here. Okay, water is a byproduct. So this is the step number 2. I will give the names to this step. So this is the step number 1. In step number 1, what we have seen, the generation of or in situ preparation of nitrous acid, that is HNO2. This is the step number 1. Then this is the step number 2. Step number 2, which is formation of nitrosonium ion. Okay, now can anybody tell me whether this nitrosonium ion is electrophile or nucleophile? You can see, guys, there is a positive charge on it. As it is having a positive charge, it will be attracted towards the negative charge. It loves the negative charge. Now as it loves negative charge means what? It loves electrons, because electrons are negatively charged, right? That is, it is electron loving species. And electron loving species are called as electrophiles, right? Electron loving species are called as electrophile. Electro stands for electron, phile stands for loving, right? That means this nitrosonium ion which we have generated here, it is the electrophile. It is electrophilic in nature. It is attracted towards the electron. So inside this I will write down formation of nitrosonium ion, that is electrophile. Okay, that is step number 2. Now let us see step number 3. Okay, this generated electrophile, obviously it is going to attack on the another reactant of this reaction, and that is nothing but your aniline or aromatic amine, right? Okay, so that I will write down now. Attack of electrophilic attack, I will write down electrophilic means of electrophile. Attack of electrophile, right? Electrophilic attack of NO plus ion. NO plus ion is nitrosonium ion, right? NO plus ion is nothing but nitrosonium ion. Okay, now here instead of writing down benzene ring again and again, okay, instead of writing down benzene ring again and again, I will write down pH. Okay, pH stands for the phenyl ring and NH2 or benzene ring. Okay, here I will write down pH is nothing but the phenyl ring. Okay, phenyl ring is nothing but that benzene ring. Okay, instead of writing benzene ring again and again, I will write down like this. It will save my time. Okay, now here you can see there is nitrogen atom which has the 2 lone pairs of electron. Okay, just one thing, I'll just expand this NH2 group. NH2 group is attached to how many hydrogens? 2 hydrogen atoms, and there is 1 lone pair of electron, okay, on nitrogen. Now this particular molecule here, the name of this is aniline, right? What is the name of the reactant? Aniline. Okay, now aniline is the first reactant on which we are going to attack the nitrosonium ion, right? Nitrosonium ion has this structure. Okay, now I will not show the lone pair of electrons on oxygen again and again, because they are not taking part in the reaction. Okay, I will just show of nitrogen. That does not mean oxygen do not have the lone pairs. They are present, but I am not showing. I hope you can understand. I will repeat. Here I will not show lone pairs of electron on this oxygen, because they are not taking part in this reaction right now. Nitrogen I will show because it is taking part in the reaction. Okay, I am not just showing, they are present there. Okay, so this is the attack of electrophile. Let us see how this attack takes place. Nitrosonium ion, it has the positive charge on it. Nitrogen of aniline has lone pair of electron on it. That is, lone pairs are nothing but the extra electron that will be given to this nitrogen ion, right? opposite attracts. Electron negative, opposite attracts. Okay, after this let us see what we are getting. So benzene ring as it remains as it is, then nitrogen attached to two hydrogen atoms, and then to the nitroso group. Right, now nitroso group's nitrogen will not carry a negative charge now, right, because it now has 3 bonds. But what about this nitrogen? This nitrogen is attached to 1, 2, 3 and 4 bonds. Therefore it will carry a positive charge, and it has given its lone pair of electron, so it will carry the positive charge, right? Okay, therefore what will happen further, that this structure which is obtained, it will lose a proton. Okay, it will lose a proton. How it is going to lose a proton? This bond will be shifted on this nitrogen, right, on this positively charged nitrogen, right? Therefore there will be minus H plus, that is there will be a loss of proton. Loss of proton is called as deprotonation. Addition of proton is called as protonation. Loss of proton is called as deprotonation. Deprotonation takes place and we get PH, NH, nitrogen with lone pair, then N double bond O, this nitrogen also with the lone pair, right? So this is the next molecule we are getting. Here can you see, this is the derivative of aniline only. Instead of hydrogen, NO group is present. Previously it was H, now NO is present. Therefore this is called as N-nitrosoaniline. It is called as N-nitrosoaniline. Okay, what is the meaning of N-nitroso? Here N-nitroso stands for, this N-nitroso stands for nitroso group is present in aniline. One of the hydrogen atom of aniline is replaced by nitroso, that is NO group, and that is attached to N, right? We have to specify that, because in aniline carbon atoms are also there. Nitroso group can be present on carbon also, but no, here nitroso group is attached to what? Nitrogen. Therefore we have to write down that N nitroso. So here this N dash stands for nitroso group is attached to nitrogen of aniline. Aniline previously was having 2 hydrogen atoms, out of which one is replaced by nitroso group. Nitroso group is nothing but NO group. Okay, yes. Now again what happens further? Protonation takes place. Now for this step I will show the lone pair of electrons on oxygens also. Why I am showing the oxygen lone pairs of electrons now? Because they are involved in the reaction from next step. Do you understand that? Okay, so what happens here guys? We are going to do the protonation. Okay, we are going to react this with the H plus. From where this H plus comes? From HCl. We are using HCl in this reaction, right? Yes, so H plus we are going to add. We are going to do the protonation, right? Now we know that nitrogen and oxygen, out of which if we compare their electronegativity, oxygen is more electronegative. Electronegativity means what? The tendency to attract the bonding electrons, right? That means it is having more attraction towards the electrons, right? Therefore oxygen will be attached to the hydrogen, opposite attracts, right? Okay, so what happens? Out of the 2 lone pairs, oxygen will give one of its lone pair to the proton and will form a bond. Okay, and will form a bond. Let us see how the bond formation takes place. Again pH remains as it is, NH, then nitrogen, then here it will be OH. Now oxygen previously was having 2 lone pairs, out of which one has been given for bonding, for only 1 lone pair and a positive charge. There are 3 bonds attached to oxygen, therefore positive charge, right? Now here oxygen has gained the positive charge, which is also not accepted. Oxygen do not like a positive charge. So what happens here? This bond is shifted on oxygen, right? This bond is shifted on oxygen. Now due to shifting of this bond, can you see this nitrogen is losing 1 bond? That is also not accepted. Nitrogen should be attached to 3 lines. Therefore what happens? This particular hydrogen which is attached to the neighboring nitrogen, this is also lost like this. Okay, this is also lost like this. So this bond will be shifted in between two nitrogen atoms. So let us see what we are getting. So pH remains as it is, no change in pH. This is nitrogen attached to the next nitrogen by double bond. Both of them contains the lone pairs of electrons as it is. When it is attached to O by single bond, oxygen also contains its both the lone pairs as it is. So this part we are getting here, right? Now here I will write down on the arrow that here we have first of all lost the H plus ion, right? Minus H plus I will write down on the arrow, right? Minus H plus I have written on the arrow. That is, this H plus we have lost in this step. Okay, then next what will happen? Again I am going to do the protonation. The same step I am going to perform again. Now why we are going to do this step? Just imagine, I just want to remove this oxygen. This oxygen cannot be removed as it is. It will be removed in the form of water molecule. So for water molecule, how many protons I should add? 1 and 2. Then and then only it will be lost in the form of water, right? That's why I am doing the protonation step for 2 times. Yes, again I will do the protonation, H plus, and that is nothing but the protonation. Okay, here again oxygen will be attracted to the proton and will form the bond with the proton like this. What we are getting after this? pH remains as it is, no change to pH in this reaction. Okay, then oxygen will be attached to how many hydrogens now? 2 hydrogens, only one lone pair of electron and a proton. So this is the protonated substance we have obtained, right? Yes, I forgot to write down the name of this compound. Here this particular compound which is produced, it has 2 nitrogen atoms. 2 nitrogen stands for, that is, this group is called as diazo group. I have told you already. So the name is diazo hydroxide. Okay, because it has diazo group as well as it has the hydroxyl group. Therefore it is called as diazo hydroxide. Okay, so what we are getting after this reaction? We will get protonated diazo hydroxide, right? This is also not stable again. Why? Because it is having the positive charge on oxygen. Therefore there will be loss of water molecule, right? There will be a loss of water molecule. Now what happens? So here okay, so oxygen will take this bonding electrons with it, and we will get minus H2 on the arrow itself. I will write down because you know that step already, I have shown it to you. And we will get the final product, and that is pH. pH remains as it is, N double bond N. Okay, now this last N will carry a positive charge. Why? Because it is attached to only 2 lines and 1 lone pair. Okay, so this is the ion. This is ion which is called as diazonium ion, right? But as we are using HCl in this reaction, there is chloride ion in the reaction mixture. Therefore the chloride ion will be a counter ion. Counter ion means what? The ion which is written to neutralize the charge present on one ion, right? Nitrogen is having, in the diazonium ion, nitrogen has a positive charge. Therefore its counter opposite ion will be chloride ion. The name of this compound is phenyl, or instead of phenyl I will write down benzene diazonium chloride. Okay, benzene diazonium chloride, which is also abbreviated as BDC. Okay, which is a diazonium salt, and this is the mechanism of diazonium reaction. Now this diazonium salt which is obtained at the end, if I write down it like this, one more time I will write it down. So this is your benzene ring, right, in which to which the nitrogen is attached directly, like this. It carries, this nitrogen carries a positive charge, and chloride ion is the counter ion, right? What happens here, this diazo group shows a resonance effect. How? Like this. What happens, this bond will be shifted in between two nitrogen atom. Why? Because this is a positive nitrogen, it needs electron. Okay, after that let us see what we are getting. We will get the ring remains as it is, there is no change to the ring. Then nitrogen, triple bond nitrogen. Now this last nitrogen lose its charge, but what about this nitrogen? It has given its lone pair, so it will carry the positive charge now, and this Cl minus will be the counter ion. So these two are the resonant or resonating structures of diazonium salt. Okay, yes, so this is how we can show the mechanism for diazotization reaction. Okay, you can just take a screenshot of this first of all. First of all, take screenshot of this part. Okay, now take the screenshot of this resonating structure as well. Okay, now you can see there is a resonance not only with the nitrogen atoms, but resonance with the ring as well. That is, this benzene ring is also in conjugation with the aromatic ring. Okay, therefore the diazonium salts of aromatic amines are highly stable, and therefore the aliphatic amine diazonium salts are unstable and they do not show the resonance, and therefore they are highly unstable. Can you see here the resonance can be with the Cl minus is the counter ion. Here the resonance can be with the aromatic ring as well, because they are in the conjugation. So here it will be like this. This will be shifted on nitrogen. This carbon will be negative now, right? So this is the another resonating structure. Likewise, this will be delocalized within the ring. Okay, you have studied the resonance effect already in the class 11, so I'll show it very fast. Here is the negative charge, then further it will again be delocalized like this. As you have studied the resonance already in the class 11th, I am doing it very fast. here will be the negative charge, and finally this will again be shifted on nitrogen. Okay, so do you understand? So there is a resonance not only with the N2, that is diazo group, but there is a resonance with the benzene ring as well. Therefore, this is very stable diazonium salt. Diazonium salts have charge on them, positive charge on nitrogen and negatively charged counter, and so this is say salt basically, but due to the resonance present in it, this is very stable. Such a type of resonance effect is not observed in the aliphatic amine diazonium salt. Therefore, they are not stable, and they are formed and they are immediately converted to some other product. Okay, these diazonium salt which are prepared here like this, they are very important organic compound because they are further used for manufacturing on industrial scale. Okay, manufacturing of dyes on large scale, on industrial scale. Dyes like benzene azo dye, then orange dye, red dye. So many dyes can be prepared by using the such a type of diazonium salt. The paints, colors which we use, for painting the walls or the houses, or so many other, like coloring the text, fabric. So all these dyes and paints are manufactured by these diazonium salts. Okay, I hope you understood. It is clear to you. And today we will stop here. Tomorrow we will discuss with some another topic. Thank you so much for your precious time, guys. And at the end, before ending the session, I'll just show you about daily practice problems, DPP. So this is a teacher's profile. Similar will be for students. You have to go to resources, then to writing material, where you will be able to see DPP, daily practice problem. You can download it. You will see all the questions over here and solve those questions on your notebook or on any paper. Just upload a picture of that solutions on the portal, your portal, student portal, and then I will solve, I will evaluate it and let you know about the suggestions wherever required. That's all for today. Thank you so much, students, and all the best to you.